Chemistry video lessons, balancing chemical equations on combustion reactions. Now, one of the things you're going to have to do in a mandatory pass exam is to be able to balance something that just says it is burned or combusted. And you know that anything that is burned or combusted means it has to have oxygen in it. And when we're talking about what we call a hydrocarbon, which as you can see, let me turn my pen on here, a hydrocarbon right here, it's not what we wanted, right here, hydrocarbon, what that means is that butane, whose formula is C4H10, has nothing but carbon and hydrogen in it. Sometimes it might have a little bit of oxygen, but there's no other element in this compound. We call these hydrocarbons. And when we have these, and we know that they're combusted, or burned, as it says here in this problem, the only products that will ever be produced is carbon dioxide and water, CO2 and water. So if we was to write this formula here, we would say butane, C4H10, plus O2 will create carbon dioxide plus water. All right? And that's how we would create this chemical equation for any combustion reaction on a hydrocarbon. And on all combustion reactions for the mandatory pass exam and for what you're going through in this unit, they will only be hydrocarbons. Now there are some basic that we need to follow when we're balancing any chemical equation, but it's especially important when you're doing it on combustion reactions, because balancing the oxygens can be tricky. So to balance an equation just means that we're going to adjust the number of elements on each side of the reaction area until they're equal. Remember, once we form the compound itself, we cannot change the subscripts, because that means you're changing the charges, and we don't want to do that. We can only add coefficients, the big numbers in front of them. So the order that you want to do is, first of all, is that you want to make sure that you are always just balancing the metals first. That's the first thing. Go through and balance all metals. And remember, when you look at the periodic table, you got that big heavy-duty stair-step line that separates metals from non-metals. The metals are on the left-hand side. After we're done with that, then we would go through and we would balance our non-metals. Now these include all polyatomic ions, okay, because polyatomic ions are always made out of non-metals. After we're done with this, we will balance the hydrogens, and at the very last we balance the oxygens, okay. Small little example. Say I have my butane here from this, and we have our oxygen and our carbon dioxide and water. Now if you're struggling with balancing chemical equations, this is what we call the beginner's way. Write down the element on each side, and I like to put them in the same order, top to bottom, so I can get a chance to see what's there. And then I just go through and I put how many I have. Okay, so I got 4, so I put a 4. I got 10 here, so I put a 10. And I have 2 here, so I put a 2. Now I go down to the other side of the reaction arrow here, and I see carbon, I have 1. And then I look at hydrogen here, I have 2 as it shows me there. And on oxygen here, I have 2 plus 1, so that gives me 3. So there's 3 oxygen on that side. Now as we talked about, we need to make sure that what we're going to do is we're going to balance the metals first. Now there's no real metals here, although carbon can be determined to be some type of a metal, but we're going to balance it first. Then we go to our hydrogens and our oxygens. So I look here and I see that I have 4 on this side. I only have 1 on this side. So I need to put a big 4 in front of here. I can't change the subscripts. I have to put a big coefficient in front of it. Now that means I now have 4 carbons, and I now have 8, 9. I just moved up to 9 oxygens right here. So there's my carbons. Now I'm going to go through and I'm going to balance my hydrogens. I look over here and I see I have 10. Okay? Over here I have 2. Well, I got to put a big 5 in front of here to make this equal 10. So now they're balanced on both sides. But this now gave me 5 plus 8. This now gave me 13 oxygens. Okay? Now over here I only have 2 of them. So I can do this 2 different ways. The easiest way is I take 13 divided by 2 is 6.5. So I'd put 6.5 in front of this. All right? Now, if you find some teacher that says, no, I don't want this to happen, you can't have a partial mole, that's incorrect, but still, they may want to have the thing where you've got nothing but whole numbers, okay? And if that's the case, it's very simple to do. Now all you need to do is multiply everything in here by 2. So you'd say this is going to be 2. We get rid of this. This is 13. Okay? This here is now 8. And this here is now 10. Okay? Now you have whole numbers in there to balance this out. Now, this way here, as we're showing you here, is really takes a long time to write all this stuff out and to go through and balance it. And when you're doing the mandatory pass exam, that's very, very hard to do. The way to do it is just as I say, is just right down the line. So you're just going to sit here and you'll start off right here and you'll just say, okay, carbon, 4. All right, I only have 1 on this side, I got to put a 4. Okay, carbons are balanced. Now move to my hydrogens. I got 10 of them here. I got 2 here, I got to put a 5 here. So now I have 10 hydrogens on both sides. Now I have 4 times 2 is 8, plus 5 equals 13 oxygens. Over here I have 2. I need to get 13 oxygens. To do that, I would multiply this by 6.5, and now I'm done. I'm already done, balanced it, it's set, ready to go, and I can move right on to the main part of the stoichiometry mandatory pass exam, and that's to do the actual calculations. Remember, just getting to this part here is just the very first part of the problem. This does not actually get you to the main part of the problem, which you're going to have to spend most of your time on doing your calculations. Make sure that when you watch this, you go back and forth over and over it as many times as possible until you feel really good at balancing these type of reactions. Remember, as always, chemists try and never, ever, ever give up, okay? Stay gritty out there.